Hi, I'm Dr. Ben Barron. In this video, I'm going to discuss the bridge between statistics and probability through a concept called statistical significance. Statistics and using data wisely is absolutely critical in managing people correctly in today's organizations. So I hope you enjoy this video. So to begin, let's start with a hypothesis. If you're unfamiliar with what a hypothesis is, check out my other video on the topic of both null hypotheses and research hypotheses. Let's start with a research hypothesis. And this research hypothesis states that managers have more meetings than non-managers. So how might we test this research hypothesis that managers have more meetings than non-managers? Well, why don't we just survey a bunch of managers and non-managers from lots of organizations and industries, and then let's see if the average number of meetings for managers, for that group, is more than the average number of meetings for non-managers. Let's imagine we did that, and we found that managers have, on average, 3 meetings per day, and non-managers have 1 meeting per day. So that's it, right? We don't need to do anything else. We found out that the managers have 3 meetings a day and non-managers have 1, so clearly they have more. We can support our research hypothesis, right? Well, not so fast. In fact, we cannot stop there. We've got to do some more. Why, might you ask? Well, it has to do with the fact that there's always a chance of error in what we've done. For example, maybe the managers in our sample were all from a few particular organizations that have lots of meetings. Or maybe our non-managers in the sample were all entry-level employees, so they naturally didn't have very many meetings. Or maybe it was something else that we completely failed to consider, some other unknown variable. In any research, we just can't rule out chance and error. In addition to the examples I gave above for potential errors in our sample, it could just be luck. It could just be chance that's influencing our results. And that brings us to the concept of significance, statistical significance. Statistical significance, or the significance level, is the level of risk that you're willing to take that your results are due to error. That's called the significance level, the level of risk that you're willing to take that your results are due to error. The significance level is something that's set by the researcher. It's typically 0.05. And having a result that is significant at the p less than 0.05 level, meaning that that's the significant level we've set. We've set it at 0.05, so we want for our risk to be less than 0.05, simply means that there's less than a 5% chance, for example, 5 in 100 or 1 in 20, that whatever you found is due to some unknown reasons or it's just pure luck. More formally stated, statistical significance is the risk you're willing to accept that you will reject a null hypothesis when it's actually true. And again, if you need a reminder about what a null hypothesis is or a research hypothesis, please check out my other video on that very topic. And so this table that you see before you helps us understand this relationship between the null hypothesis and how it relates and the concept of significance. So in the first cell, if we accept the null hypothesis and the null hypothesis is really true, I would say that in that situation, that's a pretty good situation, right? So we can say that one is good. We accepted something that was true. If we reject the null hypothesis, we say there actually is a difference with regard to these managers, getting back to my example, and the number of meetings they have. If we reject the null hypothesis, but it turned out to actually be true, then that's bad. If we accept the null hypothesis, and the null hypothesis is really false, we say there is no significant difference in the number of meetings that managers have versus non-managers, but that's not really the case, well, that's bad as well. And finally, if we reject the null hypothesis, we say that managers do indeed have more meetings than non-managers, and the null hypothesis is really false, that is a good situation. We rejected something that's false. And so again, just to use our example and go through this one more time. The research hypothesis, H1, is that managers have more meetings than non-managers. The null hypothesis is that there is no difference in the number of meetings between managers and non-managers. If we accept that null hypothesis, and the null hypothesis is really true, well, that's great. We've accepted the null, there really is no difference. Good. If we reject the null hypothesis and we say that managers have more meetings than non-managers, but that's not really true, that's what we call a type 1 error. Type 1. Now, a type 2 error, that would occur if we accept the null hypothesis. We say there is no difference in the number of meetings between managers and non-managers, but it's really false. That's not great. And finally, when we reject the null hypothesis and say that managers do have more meetings than non-managers, and there really are differences, that is another good situation. So to further understand the concept of statistical significance, it's oftentimes helpful to focus on those type 1 errors. Again, this is the error of rejecting the null hypothesis, so claiming you have actual differences in the population, for example, between managers and non-managers with regard to how many meetings they attend, when the null hypothesis is actually true. It's actually not different enough to claim that. So when I say it's true here, I'm talking about the null hypothesis. The null hypothesis is true. Again, the null hypothesis for this example is that there is no difference between managers and non-managers, between those two groups. So the null hypothesis is true and we reject it. That is a type 1 error. Our data are not different enough to claim that the null hypothesis is false. And so the significance level is really about the risk you are willing to take that you are committing a type 1 error. If we set our significance level at 0.05, that means that there is a 5% chance that on any one test of the null hypothesis, you're committing a type 1 error. It's the level of risk that you're willing to take, and it helps us understand how much confidence we have in our results. For example, a type 1 error would be claiming that managers have more meetings than non-managers, when in fact the differences aren't big enough to claim that. So in this case, if the differences aren't big enough to claim that, then the null hypothesis is actually true, and therefore we should not reject the null hypothesis. So that brings us to a very important concept, and that concept is inferential statistics. These are statistics, they're numbers that we can use to test our hypotheses using the concept of statistical significance. And these are different, inferential statistics are different from descriptive statistics. Descriptive statistics are ones that simply describe a sample. For example, the mean, the median, the mode, the variance, the standard deviation. Inferential statistics allow us to claim or suggest with a certain level of confidence that what's happening in our sample does indeed reflect what's happening in the population that it's supposed to represent. As such, inferential statistics allow us to decide whether we can make inferences about the populations from which we drew our samples. Now, there are lots and lots of different types of inferential statistics tests. I'm not going to go into all of them here. Some of them include, I'll use in my example, the t-test. You can also look at correlation coefficients. You can look at the one-sample z-test. There are a whole host of inferential statistics that help us understand whether or not differences are big enough to claim that they aren't just due to chance, that our samples reflect the population. So one common inferential statistic is the t-test. And this is a test that helps us evaluate differences in means or averages between two groups. So in the example that we've been using about numbers of meetings between managers and non-managers, two different groups, the manager group, the non-manager group, this one seems like one that might be helpful for us. I'm not going to go through how to calculate a t-statistic here, and that's not the point of this video. But regardless of the type of inferential statistic test, the basic idea is that these tests produce a number, a real number that we can look at. And that number is called a test statistic value. And this is based upon your data that allows you to decide whether your results are strong enough to be due to something other than an unknown variable or chance. So it helps us understand whether or not we can be confident in our results. I think it'd be helpful if we work through an example to show you how significance testing might actually occur. And the first step is to get our research question and our hypotheses in particular in order. So, following on the example we've been using, what's the null hypothesis? Well, the null hypothesis in that example is that there is no difference in the number of meetings between managers and non-managers. So the next question that we need to ask is, what's the level of risk that I'm willing to accept that I'm committing a type 1 error? How about 0.05? Why 0.05, you might ask? Well, 0.05 is simply what's conventional within most research of this nature. You can also use 0.01 for a more conservative type of test, but 0.05 is what's used quite commonly. So what test statistic should I use? Well, for this example, it's the t-test. Again, this video is not about what different types of statistical tests you should use, but in this example, we're comparing the means between two groups, and so the t-test is the one that we would use. Okay, great. So we can compute the t-test. And let's imagine, just for sake of argument, that our result, when we go through the process of actually calculating the t-statistic, is that we find it's 2.15. That's our test statistic value, 2.15. Okay, so we got a t-value of 2.15. Now what do we need to do? Well, we need to figure out what critical value or what number we need to exceed in order for that 2.15 to be big enough to reject our null hypothesis. And these are numbers that are already calculated for you. You can probably just Google around and find a table that describes, for example, for the t-test, since that's what we're doing right here, the t-values that are needed for rejection of the null hypothesis. And this has to do with the sample size of what we are looking at. Okay, so let's imagine that in our sample, both the manager and non-manager group had 100 people in them. We had 100 managers and 100 non-managers. And so our total sample, represented by the letter N, was 200. Okay, so we had 200 people. And for the t-test, degrees of freedom is simply the sample size minus 2. So we have 198 degrees of freedom. And this is something that we can use in our chart to then look at. Usually it's along the left-hand side. We go down and we look at the degrees of freedom, and then we go across to look at the critical value that's needed at a certain significance level. And it just so happens that for a one-tailed test at the 0.05 level with more than 100 degrees of freedom, the critical value is 1.66 for the t statistic. So our t statistic, our t value that we found from our data was 2.15. The critical value was 1.66. So that means something. The next step is to look at how our test statistic value of 2.15 stacks up with the critical value, and it's bigger. And what that means, what it means that our test statistic value of 2.15 was bigger than the critical value, it means that we cannot accept the null hypothesis. It means that the differences in our sample between the manager and the non-manager group with regard to the number of meetings they have, those differences were big enough to support the research hypothesis. And so what if our test statistic value, that 2.15, did not exceed the critical value? Or let's say we got a different test statistic value. We got a 1.5 and our critical value was 1.66. In that case, the null hypothesis wins. It means that we can't claim with confidence that the difference we saw in our sample, remember managers did have more meetings than non-managers in our sample. They had 3 meetings on average, whereas the non-managers had 1 meeting per day on average. But we can't claim that that represents the population due to the test statistic not being big enough. It means that there's too much risk that was possibly just due to chance. So let's try to summarize the idea of statistical significance by looking at this curve. You should recognize this as something akin to the normal distribution. If you haven't already, be sure to check out the video that I've posted about the normal distribution. Let's imagine that this curve right here, this curve represents all values, all possible outcomes based on our specific null hypothesis. So our specific null hypothesis in this case happened to be that managers and non-managers would have the same number of meetings. There would be no significant difference between them. But remember that we set our significance level at 0.05, which in essence is saying that we're going to treat this little area here, these extreme values. We're going to look at 5%. 0.05 is 5%, right? 5% of values in this region. And if we get one in this region, then it's probably not due to chance. This area under the curve should represent 95% of all of the possible outcomes. And so setting our critical value at this level, that's CV, means that anything that falls at a more extreme value would likely fall in this area of the 5%. And in that case, we would reject the null. In the opposite situation, if we got values, a test statistic value that fell below, that did not exceed the critical value, then we would not reject the null hypothesis because it just wasn't big enough. It could have occurred due to chance. And we know that these test statistics should be distributed in a distribution that looks something like this. And so if we get one that's really extreme enough, we can say that it probably wasn't due to chance. And that's how using inferential statistics can help us have confidence in the claims that we're making about our data. Congratulations on making it through this video all about statistical significance. I hope it was helpful for you. If you'd like to learn more about this type of topic or any other related topics, be sure to subscribe to this channel. Also, you can follow me on Twitter. I'm at Ben Barron. And of course, visit www.benbarron.com. Thanks again for watching, and have a wonderful day.